If minimum of 20 assets of an operating plant are covered in daily route-based monitoring, then it equals to 200 datasets of FFT spectrum or time waveform data. Trend analysis adds up when a dedicated vibration analyst is busy to decipher the abnormal behavior of mission-critical equipment. Assets of balance of plant may remain unattended. Generative AI models rely on machine learning, ML techniques to process and learn from huge datasets that has been fed. ChatGPT, Gemini, Copilot, Grok are AI chatbot technology. Meaning of ChatGPT chat, conversational interactions generative, highlights its capability to create coherent and contextually relevant text as response. Pre-trained refers to its initial training phase. Dedicated AI or ML tools such deep learning, multi-class SVM needs domain expertise, and many iterations are required to reach an expected accuracy level. We need to delve. Can the first layer of the screening task can be offloaded to a fairly novice in vibration analysis? Which effective tools are to be used, data-based or plot-based? Generative AI helps condition monitoring by providing predictive insights, creating realistic simulations, and transforming complex data into clear, actionable summaries for human analysis. We have selected Vibration FFT Plot as effective tool. The alarm and shutdown settings of various class of machines is guided by ISO 201816. Band-based vibration analysis uses a fast Fourier transform, FFT, spectrum to break down a machine's vibration signal into specific frequency ranges. Rather than focusing on a single, overall vibration value, this method allows for detailed examination of specific frequency bands associated with different mechanical components and failure modes. The slide picture shows various faults in a centrifugal pump based on peaks showing up in frequency and harmonics. Some free-source GenAI has the capability to advise forcing frequencies of faults as well as for anti-friction bearings if bearing numbers are provided. Based on the fault frequency table obtained on can check the spectrum of subject pump/screw compressors and select the type of anomaly. It is suggested to prepare fault frequency table for all balance of plant assets. The identified peaks at various frequencies can populated in a fishbone diagram to share with plant maintenance/operating personnel for corrective action. So far, open access GenAI is found good at creating a fishbone or Ishikawa diagram. Reinforcement learning from human feedback, RLHF, is a key component of training a large language model, LLM. Similarly to how humans learn, RL trains neural networks through trial and error. To use a open access GenAI is a bit complicated and needs expert supervision to ensure accuracy in feedback. The response should be consistent over prompts made in single session and should have insight which is normally present due to good knowledge base given during training of the module. Two different GenAI models were tested with pseudo-named as GenAI-C and GenAI-D. GenAI-C was able to accurately answer knowledge-based questions on methods and causes of machinery vibration. However, its problem-solving skills and ability to distinguish relevant and irrelevant knowledge were found limited as found in first response. We placed our prompts to GenAI as figure if it can correctly analyze the features of FFT spectrum below. Prompt made as analyze the attached vibration spectrum. Here we have observed that GenAI took just numerical values as vectors and correlated with peaks, so the response was not accurate as expected. We then put the visual prompt with labeled FFT where peaks are identified as vibration peak as shown in picture and slide prompt. Another prompt where peaks are labeled identify possible fault from attached vibration spectrum. Potential issues listed are found as generic in narrative such as high amplitude at the fundamental frequency and its harmonics can indicate issues such as imbalance, misalignment, mechanical looseness, and structural resonance. The model understood the input embedded with prompt and responded as response in the scenario where a centrifugal pump shows differing vibration levels, 4 mm per second RMS vertically and 2 mm per second RMS horizontally on the drive end, DE. This discrepancy is notable. Potential causes include imbalance. This is a primary consideration when significant variation in vibration exists between directions, especially with a rolling element bearing in a centrifugal machine. Response continued. Structural weakness. Variations in casing or support structures can cause non-uniform responses. Structural flexibility or looseness can lead to different vibration amplitudes in distinct measurement planes. Misalignment or foundation issues. Although not as common, these conditions can contribute to direction-dependent vibrations if they affect the rotor bearing system stability. However, checking for signs of structural integrity or looseness is also advised to rule out secondary influences. The response by Gen AI clearly indicates that if proper method of prompts are used backed BT-RLHF, the free access Gen AI model can effectively diagnose the potential issue with a high success rate. Sumisol does not promote the use of such open-source Gen AI on regular basis. Gen AI is just a mother who knows astronomy and answers child's questions on planetary system. A structured knowledge, such as attending a course in astronomy, provides the detailed knowledge which can be utilized in RLHF method. Turbomachinery Solutions is your trusted partner for all your turbomachinery needs. With our deep expertise, innovative solutions, and unwavering commitment to excellence, we empower engineers and organizations to achieve peak performance and reliability in their critical rotating systems. Let us guide you through the complexities of the turbomachinery industry and help you unlock the full potential of your equipment.